The liver, your bird's silent hero. A bird's liver is the epicenter of several digestive, metabolic, and productive activities. The liver serves multiple purposes, overseeing the metabolism of lipids, carbohydrates, proteins, and various other metabolic functions. A healthy liver is essential for maintaining a vigorous and productive bird. Its importance underscores the need to understand the multifaceted role of the liver, the factors that influence its function, and the importance of maintaining its health in poultry production. Metabolic mayhem. Within the poultry world, metabolic diseases pose significant challenges affecting poultry health and productivity. Simply put, metabolic diseases are diseases caused by abnormal metabolic processes, either inherited or acquired. Poultry can suffer from a variety of medical diseases and conditions that can adversely affect a wide range of systems, including regulation of bone strength, venous hydrostatic pressure, and the removal of waste products. For example, visceral gout, the accumulation of uric acid crystals in organs, is often associated with kidney failure. Osteomalacia, also known as cage fatigue, is characterized by low mineral content in the bones. Ascites syndrome is a non-infectious metabolic disease characterized by an accumulation of fluid in the abdominal cavity. This can lead to massive health problems in poultry. As the liver is an essential organ involved in the physical metabolism of the bird, perturbations in the liver can cause systemic effects. For instance, nutritional and environmental factors influence the development of fatty liver and kidney syndrome, a disease that affects young broiler chickens, with biotin being the most important factor. Faced with inadequate biotin, gluconeogenesis in the liver decreases to the point that when the bird is stressed, the liver glycogen stores are depleted and fatal hypoglycemia develops. Perhaps the most important metabolic disorder, however, is fatty liver hemorrhagic syndrome. This condition is commonly observed in caged laying hens and occasionally in breeder turkeys. Impaired lipoprotein transport leads to excessive fat accumulation, causing fatty liver hemorrhagic syndrome. This syndrome can be difficult to detect in a flock. Signs can be nonspecific, such as lethargy, increased water consumption, and respiratory distress, but often a dead bird is the first indication that something is wrong. The most common clinical signs are obesity, pale comb, dull feathers, and excessive toenail growth. There is also a seasonal influence. Hens are more likely to die from fatty liver syndrome during the warm weather months. In addition, the condition is more prevalent in high-producing hens. Several factors can cause increased deposition of fat in liver cells. These include high egg production, toxins, nutritional imbalances, excessive consumption of energy-dense foods, deficiencies in nutrients that mobilize fat from the liver, hormonal imbalance, and genetics. A particularly common factor is stress, especially heat stress. A master of metabolism. The liver is a multi-purpose organ. The avian liver, like the mammalian liver, is involved in numerous metabolic and homeostatic functions and is considered a biochemical factory. It is a vital organ involved in a wide range of functions. The fat-soluble vitamins A, D, E, and K are stored in the liver. Some members of the B group of vitamins, particularly B1, B2, and niacin, are metabolized and stored in the liver. It also stores certain minerals, such as iron and copper. As an accessory organ of the digestive system, the liver plays a major role in digestion and metabolism, regulating the production, storage, and release of lipids, carbohydrates, and proteins. The liver has many functions in the digestion and absorption of feed, but its primary function in this process is the production of bile, which facilitates the solubilization and absorption of dietary fats and the elimination of waste. The liver also functions as both an endocrine and an exocrine gland. In fact, it is the largest gland in the body. Compared to body size, the avian liver is larger than that of a mammal's liver. It is divided into two lobes. The right lobe is larger, and, in domestic fowls and turkeys, the left lobe is divided into a dorsal and a ventral segment. Each lobe has about 100,000 lobules, the functional unit of the liver. The avian liver has less connective tissue than the mammalian liver, so the lobules are less distinct. Lobules are hexagonal and consist of both parenchymal cells, hepatocytes, and non-parenchymal cells. Hepatocytes occupy nearly 80% of the total liver volume. Lipogenesis and lipoprotein formation. Fat inclusion levels in poultry feed formulations are normally kept low. Therefore, the liver plays an important role in lipogenesis and in the conversion of glucose to triglycerides. Lipogenesis in the chicken liver is particularly active in laying hens due to high estrogen levels. De novo hepatic fatty acid synthesis also depends on the availability of dietary carbohydrates. While the major products of de novo hepatic lipogenesis are triglycerides, the liver is also the major site of phospholipid and cholesterol synthesis. These lipids, along with proteins, are the components of vitellogenin. Vitellogenin is synthesized in the liver of laying hens under the influence of estrogen and is involved in the formation of the egg yolk. Fat, carbohydrate, protein, vitamin, and mineral metabolism. The liver plays a major role in lipogenesis, providing lipids for use by all tissues and the liver itself. In contrast to mammals, avian lipogenesis is greater in hepatic tissue, up to 20 times greater, than in adipose tissue. Fats metabolized in the liver come from three main sources: dietary fat, depot fat, and fat from de novo fatty acid synthesis from dietary carbohydrates. As in mammals, the digestion and absorption of dietary fats in birds occurs in the small intestine, but due to a rudimentary intestinal lymphatic system, dietary fatty acids are emptied directly into the portal blood system as very low-density lipoproteins. These very low-density lipoproteins contain 90% triglycerides and pass through the liver before entering the rest of the circulation. This unique feature predisposes birds to fat accumulation in the liver. The liver and pancreas work together to maintain blood glucose levels. The liver converts glucose into glycogen and triglycerides for storage when blood glucose levels are high, and breaks down glycogen into glucose when blood glucose concentrations drop. In response to an immediate need for glucose, the liver can convert certain amino acids and fats, as well as lactic acid, to glucose. The liver is also involved in protein metabolism and is responsible for 11% of the total protein synthesis in birds. Small peptides and free amino acids from protein digestion enter the liver through the portal vein and are transported to other tissues and organs. Excess amino acids not required for tissue protein or hormone and enzyme synthesis are catabolized. The liver produces several essential proteins, including enzymes, hormones, coagulation factors, transport molecules, and immune factors. The liver is also the site of production of blood proteins such as albumin, prothrombin, fibrinogen, and globulins. The bird's detox specialist. The liver is the body's primary detoxification organ. It is the main site of phagocytosis by Kupffer cells that destroy aged blood cells and pathogens. Toxic substances from the diet, as well as toxins produced in the body, are detoxified by the liver. These toxins include a diverse group of fat-soluble substances such as metabolic end products like ammonia and biopigments, contaminants like heavy metals, pesticides and carcinogens, anti-nutrients, and pharmaceuticals and antibiotics. Depending on their concentration, these can cause varying degrees of damage to the bird's health. The liver converts these toxins into more polar and water-soluble waste products, which are then eliminated through the kidneys and gallbladder. The liver is constantly in contact with substances that can affect its function due to its detoxification function. Mycotoxins, for example, are among the most important and widespread hepatotoxicants in poultry. Mycotoxins may have a direct hepatotoxic effect, as in the case of aflatoxin and ochratoxin, or an indirect effect derived from their metabolism, as in the case of zearalenone and fumonisin. Excessive use of drugs such as antibiotics and coccidiostats has a negative effect on liver function since most of these chemicals are metabolized in this organ. Prolonged use of antibiotics, especially for growth promotion purposes, can affect hepatocytes once they metabolize these substances. The liver, through its filtering function, is a barrier to infection. Therefore, the microbiological quality of the feed is important because an excessive number of pathogenic bacteria can pose a risk. The presence of high levels of microorganisms such as E. coli, Salmonella, or Clostridium can lead to an infection of the organ, and bacterial toxins can cause damage that permanently affects productivity. In addition, because of its metabolic function, there are byproducts that can affect liver health. One type of byproduct are free radicals. These are produced during normal metabolism, but can be produced in excessive amounts during high production periods when energy requirements are high. They are also present in diets containing oxidized ingredients with poorly preserved or poor quality fats. Free radicals oxidize other cellular components such as DNA, enzymes, or the cytoplasmic membrane. An accumulation of free radicals can lead to oxidative stress. Safeguarding liver health. Supporting and protecting liver function is key to maintaining performance. A combination of management and nutritional measures can be used to maintain liver function. An additional tool may be the use of in-feed feed additives to support liver health and function. With the real potential for hepatotoxicity, reducing mycotoxin exposure is an easy way to protect liver function. Toxin binders are an excellent way to do this. They are substances that reduce the bioavailability of mycotoxins in the feed. These additives act in the gut by binding the toxins to their surface, making them unavailable for absorption. The toxin binder mycotoxin complex is then excreted. Betaine is a major intracellular osmolyte. It maintains osmotic pressure in intestinal epithelial cells and reduces water loss. Under hyperosmotic conditions, choline uptake into the mitochondria is increased and converted to betaine to regulate cell volume. The osmolytic effects of betaine may also help alleviate heat stress and improve nutrient digestibility. Stored in high amounts in the liver, betaine also functions as a methyl donor in 1-carbon metabolism and influences lipid metabolism by supporting L-carnitine biosynthesis along with methionine from lysine. Betaine is well known in animal nutrition for its role in conserving methionine and choline. The methionine-sparing effect of betaine makes methionine more available for protein synthesis, and the choline-sparing effect makes choline more available for lipid metabolism. Choline is an essential nutrient that has various physiological functions, including as a methyl group donor, and participating in mitochondrial bioenergetics that regulate lipid and glucose metabolism. Choline also functions in the packaging and export of fats in very low-density lipoprotein and in the solubilization of bile salts for secretion. However, in-feed solutions are not the only way to preserve liver function. Another strategy is the use of nutritional supplements. These are typically combinations of ingredients thoughtfully chosen to tackle a specific problem. Often, these supplements can be administered in the drinking water, which is invaluable when feed intake is reduced or absent, or when flexibility and speed are required. Dietary feed supplements formulated for comprehensive liver support use targeted hepatoprotective ingredients such as betaine and L-carnitine. Used as an intensive short-term application on the farm, these can be highly beneficial in the support of the animal's health. L-carnitine plays a key role in maintaining liver function through its effect on lipid metabolism, and betaine is a known methyl group donor and osmoprotectant. L-carnitine is necessary for energy metabolism by transporting long-chain fatty acids known as the carnitine shuttle, into the mitochondria for oxidation for energy production. In birds, dietary fats are drained directly into the portal vein, which first passes through the liver. Therefore, hepatocytes have the ability to store triglycerides, metabolize fatty acids for energy, synthesize lipoproteins and phospholipids, or store the fats in tissues as fat depots. L-carnitine is necessary for energy metabolism by transporting long-chain fatty acids, known as the carnitine shuttle, into mitochondria for oxidation for energy production. In birds, dietary fats are drained directly into the portal vein, which first passes through the liver. There, hepatocytes have the ability to store triglycerides, metabolize fatty acids for energy, synthesize lipoproteins and phospholipids, or store the fats in tissues as fat deposits. Thus, L-carnitine works in the liver to help redirect fat into energy production rather than allowing fat to be deposited. The end result is to promote lipid metabolism by increasing fatty acid uptake and ultimately reducing fat accumulation in tissues and hepatocytes. Thus, this powerful combination of betaine and L-carnitine may be beneficial for improving lipid metabolism and energy production while maintaining liver function. A winning combination. Studies testing betaine or L-carnitine have shown to have positive effects on lipid metabolism and lipid deposition. One trial was conducted to evaluate the effects of a combination diet containing the key ingredients L-carnitine and liquid betaine on fat distribution in aged broiler breeders. The hens, 75 weeks, were divided into two groups. The treatment group was supplemented with a liquid dietary supplement in the drinking water, while the control group received no supplement. When compared to the control group, the treated group had a 20.1% lower abdominal fat weight and a 7.8% lower liver weight. Dietary feed supplements are powerful nutritional tools for improving animal health and well-being. Not only are they easy to mix, handle, and administer, but dietary supplements offer a way to deliver effective therapeutics quickly and efficiently. In addition, dietary supplements can be effective, as evidenced by the study results, which highlight the positive effects of betaine and L-carnitine on energy utilization and fat deposition. Keeping abreast of metabolic support and liver health with dietary feed supplements is one way to ensure you are supporting your bird's silent hero. I'm Dr. Melinda Culver for Biochem. Thank you for listening to the newsletter out loud. If you are interested in learning more about this topic, please contact us at biochem.net.